pyramid. Next up, going for those 3 levers from the robot's point of view, they are looking towards trying to map out their best plan of action. It can be very easy as well for that tether to get stuck in the pyramid. So the teams have to be careful with that. That is 1 lever down. They're going for number 2 as well. Kevin aiming for the 2nd lever. Seeing their point of view. Carefully lining up. And that is 2nd lever not quite fully pressed. They will realize that here in a moment when they see it still upright. Trying for your next attempt. Oh, and they are connected on it and dropping downwards. Looks like that interrupted our video feed slightly, but the lever has been switched. The library having its secrets revealed to the teams. Your final library objective. Kevin going for that last chance. The machine is being caught on it using its structure to help press it down rather than just the hook mechanism. And it is almost downwards. Looks like it is the robot slightly on its side. It caught up on the lever. Has it actually caught it in the structure? Oh, but they are free of it. Going for your next attempt on that final lever of the library. It's going to be exciting. Oh, not quite triggering the system. They're double checking. They've got to make sure that it sticks. Trying a different angle to make sure they don't get caught up on it. Will they get it in? The 3rd time is always the charm, right? So let's make sure that they can do it. They're discussing the best course of action, and the lever has been triggered. Robot tipped over, but they are righting themselves. Moving back towards the top of the pyramid, over towards the doorway where the relic room awaits. In the relic room, available to them is one of the most lucrative objectives, but as soon as it is moved, the countdown clock begins to shut the door to the pyramid. Looks like our operators are discussing the best course of action, making sure that there is plenty of tether available to them. They are observing from the top of that pyramid, measuring the height of the red marker there. As you see from their point of view, they have to estimate what that height is, and points are available. Oh, they're looking at sensor data to get the best answer for that. Still considering the relic and their best options there. Carefully navigating towards it. Now we've seen it get tipped over a few times. We haven't seen any successful retrievals. Will this time be it? They are carefully lining up. It is a very small target to aim for. They haven't knocked into it quite yet. They're very close. And, oh, just knocking it over. And it is time to run for their lives, or perhaps for their robot, as they navigate back towards the front of the pyramid. Not a lot of time left to grab it. Looks like they are a little bit lost as they're navigating towards the front based on our point of view. 30 seconds. The bubbles have started. Your water tunnel door will start closing within 30 seconds of that relic being moved. So they are running out of time as they are trapped in the relic room. Will they get through the doorway, trying to squeeze through there? Looks like they are successfully through the doorway, running out the tunnel. The door is shutting. Will they make it in time? No! They have sealed their fates within the pyramid. They are trapped. The door has shut. Oh, trying to escape. They look up, realizing there is no path forward as they have been trapped in the pyramid with the relic, never to be seen again. Welcome to the final run here at the National Underwater Robotics Challenge. Our final team is Electric Wave. They have been working hard all day to get their machine working as well as they can. Their goal is to put it into the water and see what happens. Looks like they're carefully considering their next course of action as they move it towards the edge of the pool. Currently, it is sitting on the edge as we make sure we have a camera feed from it. Just a few minutes left here. They have 5 minutes allotted for setup. After that, they get bonus points for every minute they're able to recuperate back. And it looks like we now have a video signal coming from the machine. Looks like they are getting all set up as we move forward. This is our only pre-high school team at this competition. They talked to the judges earlier today about their design process, where they reviewed the game missions and chose specific goals based on their known limitations of their team. They also used a design matrix to make mechanical decisions in terms of form factor and different thruster placement and design on their machine. We are seeing them get set up here, taking their time, making sure everything is ready to go. Looks like the machine is being placed into the water as it has different glow sticks on it, making sure that flashlight is on, and it is. You know, they were having some challenges with control scheme today. But being here is a victory, and I know these students have taken the lessons they've learned throughout this process about project management, timeline, design decisions, and limitations, and will be able to apply it to their future endeavors, not just here in underwater robotics, but also in the first technical challenge. This project was able to challenge these students as they had previously only used Java within their first tech challenge experience, and this was their first foray into Arduino, which is a C-based language, very similar to Java, but has a few differences when it comes to managing the data that is being run through it. One note from their design process is how they identified problems and tested and proposed solutions, trying to track those very carefully and document their learning so that they don't have to learn the same thing twice. It's like the robot working on crawling down the pool, making sure that they can move forward and backward as they're controlling. We see movement from the machine. I know they were having challenges with their thrusters earlier today, but it is great to see it moving here on the bottom of the pool surface. I've heard there is a rave mode here on their robot as they are able to dance around. They're moving forward autonomously. Looks like they're navigating the bottom of the pool, seeing what they can do during their autonomous runs. Looking at the different relic fragments available to them. Now, of course, 50% of the battle here is having a waterproof, a leaks-proof system. And it seems they're at least 50% of the way there as they navigate on the bottom of the pool. We can see from the view they're camped out near the pyramid. The driver is only able to see through their camera, so they're not getting a ton of information as to what their machine is doing, but they are trying to push the weight forward. And it looks like it's moving. They are moving the weight. Moving that relic fragment is almost off that pedestal. Not much that they can see from here, of course, with their camera view, but it seems they might have been... They were successful in moving it off of its starting position. We'll see what the scores end up being there. Moving back towards the shallower end, it looks like it is rather difficult for the machine to navigate. The pitch black pool does add some challenges here in Atlantis. Looks like we're having some errors on their video feed. We may have lost video feed from the machine. It appears as it crawls on the bottom of the pool. Not sure if that is on our end or on the machine's end. Looks like we are troubleshooting that loss of video. Remember, that is the only information available to the operator, that one video feed from their machine. So that is critical to the performance. Now this is what engineering is all about, is solving those last second problems. Looks like they are getting some assistance here, making sure that all the cables are properly connected. It's important to note here at the National Underwater Robotics Challenge, all age levels compete on the same set of rules. The adults, the pre-high school, the high school, and the college levels all have the same point scoring system, the same objectives, the same limitations to their machines. And the fact that anyone can do this challenge is pretty exciting. Nice work to the teams. Just being here is an accomplishment. It's been awesome to watch you run. Looks like they are retrieving their machine from the bottom of the pool. That was great work. That was our last official run here at the National Underwater Robotics Challenge. And with that, I want to send a thank you to those who've been watching from afar. Thank you for watching our broadcast here from Arizona State University Polytechnic Campus. We're very thankful for ASU as one of our organization sponsors, along with Blue Robotics, NXP, Microchip, State Farm, Boeing, and our founding sponsor, the Si Se Puede Foundation STEM Center. Thank you to all teams who competed, and congratulations to everyone. Everyone had to give a technical presentation to a panel of judges in addition to performing the robot tasks. It's been a challenging and exciting weekend for all involved. Very proud of all of our participants this weekend so far. And thank you to all who tuned in from across the world.